Okay, so I had this video request to have a look at a question of this sort, where we just really apply the Henderson-Hasselbalch equation, and I think it's possibly the word in this question will catch you off. So we're finding the ratio. In this case, it's propanoate to propanoic acid, which should really put concentration is what I meant to put in there. Sorry. So concentration in an acid buffer, we're given the pH and we're told the pKa. So let's just write down the equation that we've got. So pH is pKa plus log A minus over HA. Now if we figure out propanoic acid, that would be CH3, CH2, COOH, COOH, split it up. So that's propanoic acid, split up into H plus, and its conjugate base, propanoate. So that proton just drops off on the alcohol group, OH group, hydroxy group of the carboxyl functional group. So what we've really got is just putting numbers into an equation. So I've got pH is 4.5 and the pKa is 4.88 plus log. Now the conjugate base is the propanoate. Right, and the HA is just the propanoic acid. And I've just got to rearrange this equation slightly. So I take away 4.88, so I'm going to do 4.5, take away 4.88. I'm going to have minus 0.38 on this side, and I've still got the log on this side. Okay, the opposite of doing log is doing 10 to the power of. Okay, so rearranging that equation then, 10 to the power of that is going to equal what's in the log. So this ratio here is 10 to the minus 0.38. Which gives us 0.418. Keeps going on. Because this was the 2 sig figs, I'm just going to give this the 2 sig figs. Okay, so 0.42 would be the ratio. Oh well, that would be when I divide them, so that would probably count as the ratio. I'd have no units because the concentrations cancel. If you want it to be mathematically correct and definitely have a ratio to it, then we're thinking about what that means. So the ratio of propanoate to propanoic acid, well, it's 0.42, so that means if this is 42, this is 100, because I can write it as 42